Hello everyone and welcome to today's webinar. My name is Scott Bush and I'm here with Joe Lichman. He's Attivio's VP of Technology. Joe's going to take us through Attivio's patented query time join technology in just a bit, but first a little housekeeping. This webinar will be recorded. Everyone who registered will receive a follow-up email with a link to the video recording and the slide deck that you can share with your colleagues who couldn't attend. And if you look over at the right-hand panel, there's an area for you to submit questions. We love your questions, so please ask away. We'll leave some time at the end to get to as many as possible and see if you can stump Joe here. All right, let's dive right in to today's topic. Joe, over to you.
Thank you, Scott, and thank you everyone for attending. So today's webinar will be about Attivio's query time join capability. This groundbreaking and patented capability allows Attivio to combine the precision of a relational database with the flexibility and linguistic analysis capabilities of a search engine. While query time join is a standard capability in a relational database, Attivio is unique in that it can work with information regardless of format, handling structured and unstructured information with equal dexterity. With Attivio, you get a schemaless universal index that can maintain the relational nature of structured data and build structure around unstructured data, unifying these disparate data types and enabling a wide variety of high-value use cases. With this unique and powerful capability, query time join delivers on a number of key benefits for customers. First, operational efficiency. With other technologies, you must predefine the schema or flatten data. Not so with Attivio. With Attivio, there's no need to flatten data or call external systems with every user request to fulfill a use case. We also enable dynamic user experiences. With other technologies, you may have to sacrifice user experience to make data work in your application. Again, not so with Attivio. With Attivio, you can build your user experience as you like and count on Attivio to be flexible enough to handle the data no matter what the format. And finally, you can find relationships between disparate data sets with Attivio. No other technology in the market handles structured and unstructured data as completely as Attivio. With Attivio, all data can be analyzed in the same application and opening up new paths to insight and value. So let's talk about really what this means and how query time join works and how you might use it. So let's talk about a generic product search use case. Maybe this isn't a use case, but we can talk about all this implies when you build any kind of search application, really. So when you look at the elements that make up a searchable object in a product search, the central object or document is the product itself. This usually contains the product description, maybe an image, and some additional fields such as category and manufacturer. Each product is likely a row in a database. So each row becomes one document in the index. This database is probably fairly static. You don't add new products that often, so maybe you'll have to add a new product or update a product on a weekly basis. But if your business has any notion of entitlements and want to filter documents in any way, then you will also want to index your customer information along with the products. That will make you sure that customers only see products that they are entitled to see. In other words, you want to filter out some products that match the user's query, but you don't want them to see. To do this, you will need to find all the products that a customer has access to and write the customers directly into the document. It's likely that this information changes maybe on a daily basis. So now you're looking for updates on a daily basis. So products may not be the whole story. You may have parts. Each product may be made up of a set of parts, and these parts are not one-to-one. They may appear in multiple products. This is a completely separate table generally, and that is related to the product table in a variety of different ways. So you may find a hierarchical relationship here, and you probably want to allow users to find products by searching on the component parts. So let's write this information into our product document as well. This database is probably fairly static, similar to the product database. New parts updates might happen maybe on a weekly basis, but you need to figure out which products need to be updated every time you add a part. So it isn't a one-to-one match. You have to figure out those relationships. So again, we're building this product data set. And is there anything more annoying than when you go to checkout on a commerce site and being told that the item you have is that you've selected is out of stock? Or maybe as the business owner, you want to highlight products that you need to move because they're high in stock and maybe overstocked, and you want to offer a discount. If you want to do these things as part of your search application, you will need to write the orders into the product document as well. This is a highly volatile data set of structured information. You could expect to have an update to your index every minute or even more, or you may have to leave this information out. The user experience, if you do leave it out, will suffer, and you will lose the opportunity for your search application to market overstocked items. You will lose the ability to deal with to tell customers that something's out of stock before they've gone to moved on in the application. And if you can't manage these updates, this is what you'll have to sacrifice. This is a highly volatile database, again, written into the document. You might also look at an unstructured data set like customer reviews. Customer reviews are a powerful tool for selling your products and are a great addition to the user experience. This is a big set of unstructured data that can be added to the product pages, but they are user-generated. They change a lot. They change in unpredictable ways. Ideally, you'd want the reviews to be searchable, and you want them searchable immediately. Sometimes these will come in bunches. Sometimes they won't update for a few days. Again, they'll be one-to-one with a product, but when they change, you'll have to find out which products are relevant, or if they're reviewing parts, that could be another complexity. But again, something that you need to add to the document that affects the operational management of the information. So okay, so now we have our complete document. It's products, it's customers, it's parts, it's orders, and it's reviews. So what's really happening here? Basically, you are flattening a bunch of tables to fit them into the document model. You are collecting unstructured information and writing it in. They have different update frequencies, and each time a change occurs, you are running queries to figure out which documents have to be updated and with what information. You are coordinating all this across multiple tables that are being updated in an almost random fashion. It is what it is. It's a big ETL, extract, transform, and load process, one that will require a lot of coordination and more than likely a lot of trade-offs. This ETL process will take time to build and will take time to operationalize effectively. So once you've got it running and maybe you're happy and it's working for a while, what happens if you need to add something new? That is inevitable. Someone will come in, a business person will come in and say, I've got an idea. We've got these product manuals. They're great information. I want to start selling to partners perhaps, and they need the manuals. So what happens when they add this element to the product? It's just another unstructured data set. The engine should be able to handle it relatively easily, but now you have to extend the model, and you need to update every single bit of data in your index. And really, this flattening is chaos. You are no longer flattening the data. The data is flattening you. So how could you handle this scenario with Attivio? With Attivio, each of these data sets would be indexed independently. You would join them at query time. You wouldn't flatten data or pre-join anything. No ETL is going to take place. You would be able to add new elements or ask questions that you didn't know in advance without having to redo your entire document model and re-index the full data set. So by being able to add these, you can ask these interesting questions that you may have not thought of in advance. So let's look at the model again. This is the product-centric view of what Attivio would look like solving the same exact use case. Each element remains in a separate table, each updated on its own schedule or based on real-time events. So now you have the parts database, the customer database, the reviews, the orders, and the products all independent, updating on their own. Orders is updating as often as you like. The parts their hierarchical relationship is maintained. And really, it's how you construct the query that defines how these relationships work. And if you come up and you decide you want to start adding a new application, So maybe you want to take the same data, these products, and instead of selling directly to customers, you want to have your partners who resell them work with you. And perhaps you want to add trouble tickets and support off the same index. If you want to start filtering based on partners to support this portal, simply add that new table and modify the query. If you want to add support tickets to this new application, simply add the unstructured data set to the index and again, modify the query to support it. And with a new query, you now have a completely new application being run off essentially the same data set. Here, we're taking a customer-centric view. That is the centerpiece of this application. Now you can search for tickets that are related to a specific set of products that are being used by a specific set of customers. A whole new application has been brought online without having to rebuild your entire index. Operationally, this is far easier to manage and infinitely more flexible than flattening and ETLing data into a predefined document model. So that's a sort of generic use case on how you might think about using query time join. Doesn't have to necessarily be a product database. We don't work with just e-commerce sites. In fact, that's just one part of our business. But if you're saying to yourself, this is nice, but I'm building a knowledge management or customer support application, I'm not sure I need this. If security is important to you, and of course it is, then here's how query time join is important to you. With a security in a search application, you have two common options, early binding and late binding. So let's go over early binding. With early binding, all the critical information, access control lists, and user groups from LDAP and Active Directory are written into the document as part of the ETL process, the same exact process I went over before. This document is then indexed with the information. This is a reasonable approach from a performance perspective, but is extremely challenging when changes occur. If a user moves from one group to another, or security changes in any way, you have to find all the affected documents and rerun them through the ETL process and then reindex them. Operationally, this is a nightmare for just about any organization of any size. And if you make a mistake, your application can be down for hours or days. Now, if you don't want to ETL the security information into the documents, you can at query time do separate lookups. You could do late binding and resolve the security in the front end. This works, but the downside of this approach is that queries are slower as you do a second lookup. You're placing a huge burden on external systems. And worse yet, many search features are significantly hobbled or have to be removed. Things like aggregations or facets, suggestions, even basic hit counts will be incorrect as documents are filtered out for security. Rather than show incorrect information, most front ends disable these features altogether, negatively impacting the usability of the system. Now, Attivio is different. It's fundamentally different. Attivio leverages its unique patented join and graph operator to deliver security that is both performant and easy to manage. Attivio indexes security policies from source systems and users and groups from Active Directory and LDAP as separate tables in the index. When a user performs a search, Attivio joins the documents to these security tables and filters out the data users do not have access to. Since this is in the index, the query is performed in milliseconds. When access control needs to be updated, Attivio simply updates the single table in the index, no expensive reingestion, and no reindexing required. This is an out-of-the-box feature for Attivio. If you get Attivio, we leverage these fundamental capabilities as part of the way our system works, leveraging our query time join, leveraging our graph query, and by doing so, this comes out of the box for Attivio. So to recap, no matter what your use case, query time join provides three key benefits. Operational efficiency. With other technologies, you must predefine the schemas or flatten data. Not so with Attivio. With Attivio, there's no need to flatten data or call external systems with every user request. Dynamic user experiences. With other technologies, you may have to sacrifice user experience to make data work in your application. Not so with Attivio. With Attivio, you can build your user experience as you like and count on Attivio to be flexible enough to handle no matter what the format. and find relationships between disparate data sets. No other technology in the market handles structured and unstructured data as completely as Attivio. With Attivio, all data can be analyzed in the same application and opening up these new paths to insight and value.
All right, thanks, Joe. A reminder that you can ask questions. There's a panel on the right-hand side. We would love to take any questions that you have. We have plenty of time here, so see if we can stump Joe here. In the meantime, Joe, I'll just ask you a question here. So often is the case that we run into folks that are trying to do it themselves. They're trying to perhaps take open source software and they get together with developers and say, hey, let's build this ourselves. What would you say are maybe the top 2, 3, or 4 things to watch out for if you're going to try and do it yourself, whether that's immediate or something you might see down the road where you would dissuade them from going that direction?
Yeah, so there's a couple of things. I mean, there's a lot of the capabilities, including to some limited extent, even some joining capabilities in some of the open source technologies. And while these technologies are powerful, they require a great deal of experience. They require a great deal of effort to bring together in a way that allows you to build an application. So while you can accomplish a lot of your goals if you're willing to, if you have a large, dedicated and talented team, it is possible that you will be spending a lot of time focused on issues and on technology that is not central to your business. With Attivio, a lot of these things will be packaged in. So you can wire in some additional text analytics to try to approximate some of the things Attivio does. That's going to be an effort. That's going to be another technology you're going to have to master. If you are going to try to hook up your, if you want to add some BI tools to or reporting to your application, that's another complication you're going to have to bring in. If you need to connect to data sources, you're going to have to build or find connectors. Again, if you want to buy all the parts and put it together yourself, that is something you can probably come pretty close to doing. But the time to value will be dramatically diminished, and your ability to support that application and extend it will also be severely hampered.
Great. Okay. Here's a question. How good is the query performance? Is it sub-seconds like traditional search query? What if we have to join 2 indexes each having 50 million records?
So there are definitely performance considerations. So and there are optimizations that can always be applied. So generally speaking, for example, in the way we apply security and the way we build the index, it's always sub-second. That's search performance. If you know you're going to be working with certain data sets, you certainly can apply things like caching and co-locating of partitions. The larger data sets, you certainly, the closer you can co-locate it. So if you're building a search application, you're focused on putting the data together in some way that's going to improve performance. But you will always be able to query across those large data sets. Really, it's a matter of how what the hardware you put at it. So we could certainly join those 2 large data sets. You would probably need more hardware in that case.
All right, part 2 of that question, what are the limitations? What if I have 10 tables each having a minimum of 30 million with 200 attributes / columns each, and if we have to join many tables for a given query, like maybe 8 to 10 table join, is there a known limitation?
There's no limitation in the way, that's been, that you've articulated that. The larger data sets, the more joins you do, you're certainly going to see, some performance challenges or slowdown. It's not like any database, the larger the data sets get, the more tables you join, the less performant it'll ultimately become. And you may find some reasons to cache certain commonly join tables, for example. But defining the limitations, obviously it's limited by how much memory you have and how much disk space you're looking at and throughput.
All right, this may be related. Does it work with big data situations, for example, where a few billion rows are in a table, joining with a table in S3 with 100 million rows, or 53? Read that.
You're definitely in the high end of what you're doing, and you're not going to be performing anything like that big data analysis on at sub-second speeds. This will be more akin to using something like Hive or an Impala if you cache the data correctly. But these are use cases that people have certainly tackled with Attivio.
Great. And what are the list of out-of-the-box connectors available?
We can send you that. You can go to our website, but it ranges from pretty much any JDBC interface. Basically, you can break down the set into common interface standard protocols like JDBC, ODBC, file systems, Windows and Linux, HDFS. So any of those interfaces, there's standard applications for it. And then there are also application connectors that have use proprietary APIs, things like SharePoint, Exchange, Jive, Confluence. The list is roughly 50 long, and then you include all these all databases and whatnot that have standard interfaces using SQL and things of that nature. And we also have a web crawler if you wish to crawl web content.
All right. And what is the database name where all ACL info is stored? Oracle, SQL Server, or homegrown?
It's in the index. So we actually index that data in the Attivio index as part of our application. I guess you'd call it homegrown, but it's just we're effectively we have a connector for Active Directory, we have a connector for LDAP. We will pull that in just like we would pull in information that we would from Oracle, but we keep it in our own proprietary index.
Great. And can you do a multi-level group by and order by on a join query? Any limitations on that?
We can do I'll have to check in particular. We'll have to ask that question to support. We definitely do multi-level. We definitely do group buys. I'd have to test and make sure we could do that exact sequence. Or you could certainly go to our website, sign up for answers.attivio.com and look through the documentation to see if we support that. Or download the software for free and give it a shot.
Yeah, that's a good segue, Joe. We exhausted all the questions here. Those were great questions. Segues over to the right here where you can see where you can download the Attivio platform and try it out for yourself, see how that works. Also, if you're interested in the next webinar that's coming up later this month, and this will actually be a case study format where Tom Cody of Thermo will go into the specific case study that they have, and we'll open that up to questions at the end as well. But we need to wrap this up now. Thank you everyone for joining today, and have a great rest of your day.